Hello and welcome to Unit 2, Lecture 4 for Introduction to Logic. We're learning derivation still. We're learning a new kind of derivation today called an indirect derivation. And like a conditional derivation, this is a whole new way of setting up a derivation. And the idea behind indirect derivation, which we're going to end up using a lot, is to show that something couldn't possibly be true because if it were true, it would lead to something absurd, something impossible, a contradiction. This way of proving something is also called reductio ad absurdum in Latin, which means reduction to absurdity. This can't be true because if we assume that it's true, we get something being both true and false. And to do this, we need a special symbol. This is a dark X. I'll tell you how to do this on a computer in a bit, but this dark X means a contradiction. And we get this dark X on a line of a proof if we read something absurd. So we need this rule called splat in. I pronounce this dark X splat because we're going to run into a contradiction if we assume something. If you have A being true and A being false, and one line that says A is true, another line that says A is false, you get this thing called splat. If you make an assumption and it leads to splat, you know the assumption is false. So the way you set this up in a derivation is you're trying to show that something's false. You assume that it's true, and then you show splat. I'm going to skip over some text here. We'll do it in an actual problem. Suppose this is the problem we're trying to do. Premise 1, if A is true, B is true. Premise 2, if A is true, B is false. Show that A is false. We're going to show that A is false using our new proof technique, indirect derivation. So in this box over on the right, we're going to write ID for indirect derivation. The next thing you do is you assume the opposite of what you're trying to prove. We're trying to prove that A is false. We're going to assume that A is true. So I'm going to write in ASS for assumption. Then we get a new show line to show splat, show a contradiction. Now you can put splat into the computer. It's not a normal X, so you can't just write X. You either do 2 X's or you can do the hash mark. When I handwrite this, I do a double stroked X, so that's why it kind of looks like this hash mark. So that's how you type in the dark bold X into the computer. And that you show by direct derivation. So we're going to show splat by direct derivation by using our assumption along with our premises. So we've assumed that A is true. According to line 1, if A is true, B is true. So we get that B is true from 1 and 4. We also get that B is false from 2 and 4. 2 says if A, then not B. So by 2 and 4, we get that B is false. If we get that something is both true and false, on the next line, we put in a new line, we put in splat. So again, 2 X's or the hash mark to put in the bold X. Over on the right, you write the 2 lines that contradict each other. So the 2 lines that contradict each other in this problem are 6 and 7. And the rule is splat in, double X in. So we've shown splat by direct derivation. The way indirect derivation works, if you assume the opposite of what your original show line, and you succeed in showing splat, if I cross off this show line for splat, I can cross off this show line as well. That's the way indirect derivation works. Right? If you assume the opposite of what you're trying to show, succeed in showing splat, you can cross off the show line for the thing you started with. Let's do another one. Either P if and only if Q or not A. If A, then P, not Q, show not A. So we're going to do this by ID, indirect derivation. We're going to assume that A is true, then show a contradiction, show splat. We always show splat by direct derivation. So you're already doing an indirect derivation. The show splat is inside the indirect derivation. You do that by direct derivation. All right, so line 1 says either P if only if Q or not A. To use that, we need the negation of one of the 2 sides. So we either need not P if only if Q or not A. We don't have not A, but we can get not A from line 5. So 5 double negation gives us not A. That gives us what we need to use line 1. So we get P if and only if Q. If one side is false, the other side has to be true. So that's 1 and 7, wedge out. If A, then P, line 2 says, I have A at line 5, so I get P. So by 2 and 5, arrow out, I get P. So I'm going to jump down to line 8. Line 8 says if P then Q. So I get P if and only if Q. So I get if P then Q from that. So I double arrow out on line 8. I have P, so I get Q. I could also do the modus tollens on 10. I have not Q, I could get not P. So sometimes, happens quite a lot actually with these indirect derivations. There's more than one way of doing it. But I'm going to do if P then Q, I have P, I get Q from 9 and 10. Arrow out. Now the Q at line 11 contradicts the not Q at line 3. So the lines 3 and 11 contradict each other. So we write in a line that says splat. And we write 3 and 11 splat in. So I've shown splat, therefore I've shown not A by indirect derivation. Okay? So the idea behind indirect derivation, again, trying to show something's false, you assume that it's true, then you get a contradiction. So let's do one more. So if P, then N and M, either Q or not N, show not both P and not Q. So we're trying to show a negation. We'll do it by indirect derivation. Assume the thing without the negation at the beginning. So it doesn't matter if what you're trying to show is complicated. You can still use indirect derivation. We'll assume the entire opposite of what we're trying to show, then show splat. So I have an and statement at line 4. It's good when you get an and statement to break it up into its two halves. So I'll break up line 4 into its two halves. So we get P in one line, not Q in another line. Now I can use line 1. If P, then both N and M. I have P, so I get N and M from 1 and 6. Arrow out. So line 2 says either Q or not N. I have not Q at line 7, so I get not N. It's either Q or not N. Oh, what did I do there? I put in a P rather than an O. So I get not N from 2 and 7, wedge out. I can get N from line 8. I need to have it on a line by itself, ampersand out. So now these two lines 9 and 10 contradict each other, so I can put in splat, 9 and 10 splat in. I've shown splat. So once you've shown splat, you've shown the show line above it when you're doing an indirect derivation. Okay? Now, strictly speaking, there are two forms of indirect derivation. There's one where you're trying to show something's false and you assume that it's true and that leads to a contradiction. You're also allowed to use indirect derivation to prove that something's true by assuming it's false and that leading to a contradiction. So the difference is very subtle. In one, you're trying to show a negation and you assume the thing without the negation and you get a contradiction. The other one, you're trying to show something without a negation and you assume it with a negation and you get a contradiction. So here's one where you do the other form. We're trying to show something true by assuming it's false and showing that that leads to a contradiction. So again, this is indirect derivation. I'll write ID. We'll assume not P. We're trying to show that P is true. We're going to assume that P is false and show a contradiction. So I've assumed not P. So P or Q and not P gives us Q. Oh, we'll do this by direct derivation now. So we get Q from 1 and 4, wedge out. If Q then P, we have Q now, we get P. We could also, again, do modus tollens on line 2 and get not Q. You can do either one. Either way of doing it is correct. We don't care which way you do it. There's always multiple ways of doing these problems. So if Q then P, we have Q, we get P from 2 and 6. Arrow out. So, oops, I haven't shown that yet. So now I have two lines that contradict each other, not P and P. So 4 and 7 give me splat. All right, 4, 7 splat in. Now I've shown splat, therefore I've shown P. I'm going to skip this one. And this is another one you can do by proving something true by assuming it's false and getting a contradiction. You're allowed to do indirect derivations within conditional derivations or vice versa. So this one I'm going to do a conditional derivation, and inside it I'll do an indirect derivation. So I'm trying to show if P then Q. So I'm going to do this by conditional derivation since the main operator of the show line is an arrow. Whenever the main operator of the show line is an arrow, I do it by conditional derivation. So let's remind ourselves how conditional derivation works. We're trying to show that if P were true, Q would be true. So we do that by assuming that P is true. The new show line to show that Q is true. Now I don't have to show Q is true by direct derivation. I can show it any other way I want. I'm going to show it by indirect derivation. To show that Q is true, I'm going to put in indirect derivation, assume not Q, and try to show a contradiction, try to show splat. Splat you show by direct derivation. So now I'm doing an indirect derivation within this conditional derivation. So the lines I can work with are 1, 3, and 5. I can't use any of the show lines until they're crossed off. But I can use 1 and 3 together, and I get Q or R and not P. Because if P, then that. So I have P at line 3, so I get that. Now I have an either or at line 7. I have not Q at line 5, so I get R and not P. P. From 5 and 7, wedge out. I can get not P from that and break out that and statement to either of its halves. I don't need the R. But the not P is going to give me a contradiction. So now I have a contradiction between line 3 and line 9. I can write in splat, 3, 9, splat in. So now I've shown splat, and the way indirect derivation works, you assume the opposite of what you're trying to show and get a contradiction, you can cross off the show line for the indirect derivation. And the way conditional derivation works, if you assume the if part, cross off the show line for the then part, you can cross off the show line for the conditional derivation. So I'm done with this problem now. Okay? All right. So more rarely, you can do a conditional derivation within an indirect derivation. It's not quite as straightforward because there'll be a direct derivation in between. So let's see how this problem works. This is kind of a funny problem. If R then not, if P then both P and Q. Q is true, show that R is false. We're going to do this by indirect derivation. We're going to assume that R is true. A new show line to show a contradiction. We always show splat by direct derivations, and whenever your show line shows splat, you say show that by direct derivation. You can't show that by conditional derivation since it's not a conditional. But now that we have that, we have 1 and 4, we get if P, we get not if P, then P and Q. From 1 and 4. Now, if I want to finish this problem, I've got to get a contradiction. But what I just got seems false. It seems it's true that if P, then both P and Q. I should be able to show that. Remember, you can put in a show line whenever you want. I can show the opposite of 6. I'm trying to get a contradiction, so I want to show the opposite of something I have. I can get the opposite of 6 by putting in a show line to show it. Show P, if P, then P and Q. Now that seems true because Q is true, so if P were true, P and Q would both be true. So this I can show by conditional derivation. This is a conditional. So I'll assume P, do show line to show P and Q. I'll show that by direct derivation. I have P and Q on separate lines. I've got P on line 2 and, Q on line 2 and P on line 8. So I get P and Q from 2 and 8 by putting those two together. So now I've shown P and Q. And the way conditional derivation works, if you cross off the show line below it for the then part, you can cross off the show line for the conditional. Now I can't cross off the show line at line 5. That's a direct derivation. I need to get that exact line inside a box. But notice that 6 and 7, I can use 7 now the show is crossed off. 6 and 7 contradict each other. So I'll put in a line for splat, and I'll write 6 and 7 splat in. Now I've shown splat, and therefore I've shown this by indirect derivation. So there's something you want to show, like this conditional, because that would give you a contradiction. You can put in a show line for it, and if it's conditional, you can show it by conditional derivation or by indirect derivation. It often makes sense to do two indirect derivations to show an and statement. So let's show how that works in this problem. If A, then B and not B. Either C, or if D or not C, then C. Show both C and not A. When you're trying to show an and statement, oftentimes this is the way you should do it. You don't write indirect derivation by the show line for the and statement, you write direct derivation. But immediately under it, you write a show line to show the first part of the and statement. And you do that by indirect derivation. So we're going to show C by indirect derivation. We're going to assume not C. That's how indirect derivation works. You assume the opposite of what you're trying to show, and then you show a contradiction. If C, either C or this long thing over here, according to line 2. So we have not C, so we get this thing over here. D or not C, arrow C, because it's either C or that, but it's not C according to line 5. So 2 and 5 wedge out gives me that. I don't have D or not C, but I can get D or not C by doing wedge in on 5, right? So if you have half an or statement, you get the whole or statement by wedge in. So then I get not C, or get C from 7 and 8. Splat, C is both true and false. 5 and 9 contradict each other, so I get splat. So now I've shown this by direct derivation. I've shown splat. The way indirect derivation works, if you assume the opposite of what you're trying to show and you show a contradiction, you can cross off the show line for the indirect derivation. I can't cross off the show line for line 3 yet. That's a direct derivation. I need to get that exact statement inside a box. But now I've gotten half of it. I've gotten the C part. Now I need to get the not A part. I'll get that by another indirect derivation. So I'll put in a show line to show not A, because I want to show not A. I can do that by indirect derivation. I'll assume that A is true and show a contradiction. So if A, then B and not B. I've got B and not B now from 1 and 12. Remember, once you draw boxes around things, they're gone. So I can't use these splats at 6 and 10, but they're inside a box. So I can use line 1, since line 1's not inside a box. So 1 and 12, it's not splat in, that's arrow out, sorry. Gives me B and not B. Now, B and not B obviously contradict each other, but I need them on lines by themselves to use splat in. So I'll break up line 14, get B on one line, not B on another line. Now I have my contradiction. 15 and 16, I need 2 lines that contradict each other. That's why I need to break up line 14. So now I've shown this splat, therefore I've shown not A. I can't cross off the show line at 3 yet, but I can use lines 4 and 11 since I've crossed off these show lines. Now they're regular lines, I can use them. So 4 and 11, putting those together by ampersand in, I get C and not A. That's what I was trying to show. So when you're trying to show an and statement, it often makes sense to do 2 indirect derivations and then put the results together at the end with ampersand in. Okay? There's one other rule that has to do with the splat called splat out. If you have a contradiction, if you have splat on the next line, you can write whatever you want. And we never need to use this rule because the only time we ever deal with splat is when we're doing an indirect derivation. If you're doing an indirect derivation, the show line is splat, so once you get splat, you can stop there. But if you didn't stop there, you could get anything you wanted on the next line. So splat out, it's just there, so there's a companion rule to splat in. There's splat in and splat out. But you never need to use splat out, so I'm not going to talk about it anymore. So that's indirect derivation. We'll look at some more uses for indirect derivation and some more strategies in our next session. Thanks.